Okay, today we're going to look at trigonomic identities, and I'm going to go through the basic identities. That identity means two things that are equal to each other. And in grade 11, what the key thing is tangent theta actually equals sine theta over cosine theta. Now, there's actually a little bit of a proof for this. I'm going to show you right here. Do you know if you take a triangle and go ABC and put an angle down there and call theta, and you think of SOHCAHTOA, a sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, and tangent's opposite over adjacent, you can see here sine would be B over C, opposite over hypotenuse, and cosine would be A over C, adjacent over hypotenuse. Well, there's sine over cosine. But you know what you do with a fraction when you put it in the bottom of a fraction is you invert it, you tip it, and you times. Hey, those C's will cancel. You'll be left with B over A. But B over A is actually the tangent. So sine divided by cosine is equal to the tangent of this angle. Similarly, if you'd go A over C is cosine, B over C is sine. If you square these things, you'll get A squared, you'll get B squared, you'll have a common denominator of C squared. And when you add them, you write down C squared, you go A squared plus B squared, but you go, hey, wait a sec, A squared plus B squared, by Pythagoras, that's equal to C squared. And anything divided by itself must equal 1. So that, in a way, these pictures are sort of, they're illustrating, they're just about proving that sine squared plus cos squared equals 1, and the tangent equals sine over cosine. Now, these were some different questions we did. I want you to take a look at this first question here. The problem is you're supposed to prove that sine x cos x tan x is equal to 1 minus cos squared. Well, what you do is you start with one side, and I start with the side that's the most complex, sine x times cos x, and because tan x equals sine over cos x, you can rub it out. You can get rid of it, or you don't get rid of it, you replace it with sine x over cos x. Now it's all about fractions. You're multiplying by sine x, but you're dividing by sine x. And those two operations, multiplying and dividing, they cancel. So that cos x cancels with that cos x, and you're just left with sine times sine is sine squared x. Well, sine squared x, if we take this sine squared plus cos squared equals 1, and we subtract cosine squared from both sides, we'd get 1 minus cos squared. So sine squared is really 1 minus cos squared. And that equals the right-hand side. That's what we were trying to prove. So you keep working the left-hand side until you can get it to look like the right-hand side. And you write it down just in this form. Okay, well, that's it for now. We'll try some other identities in a bit. Okay.